Hi everyone. I want to start by thanking you all for your time today. I'm excited to present to you on our journey of enabling immersive 3D planning for the future of Victoria. By way of introductions, my name is Justin Madex and I'm the manager of the Spatial Services team at the Department of Environment, Land, Water and Planning in Victoria, Australia. My team is made up of 17 spatial experts with a variety of skills and experiences. We're the planning department's spatial team and go-to point for anything they need that relates to mapping. Over the next 30 minutes, I'm going to share with you our journey of enhancing our spatial implementation, identifying the shortcomings, developing a 3D roadmap, and ultimately delivering a powerful solution using the ArcGIS suite of technologies. This journey has been one of great learning, and I'm keen to share with you the lessons learned along the way. Victoria's Planning Department manages a range of complex statewide spatial datasets. As little as 3 years ago, we were working with ineffective, outdated technologies and not embracing GIS to its full potential. Over the past few years, though, we have invested in the ArcGIS stack to allow us to more efficiently manage the datasets through server and desktop tools, along with enriching the planning experience through the spatial analysis and geoprocessing capabilities that are now available to us. So what are we actually responsible for in the Spatial Services team? Well, first and foremost, managing and maintaining the Victorian planning scheme. At a high level, it consists of 83 schemes across the state, and those 83 schemes include over 50,000 planning zone polygons and over 80,000 planning overlay polygons. We also provide a mechanism for the Minister for Planning to review permits and applications across the city, in particular undertaking visual assessments on how these new developments will impact their surroundings. And of course, we provide advanced spatial analysis to the planning group, be it in the form of raw data, a variety of spatial analysis, and of course, high-end cartographic products. By leveraging the full potential of the ArcGIS spatial tools available to us, we've been able to introduce a great deal of efficiencies in our management of the planning scheme, minimizing manual tasks, and ultimately directing our attention to more high-value work. But one area that was still disconnected and difficult to utilize fully was our 3D platform for visualization and analysis. This was a bespoke, disconnected, and non-spatial application, which was limiting our ability to fully embrace 3D spatial analysis. The time had come to reevaluate our 3D implementation, but we quickly came to the realization that it was time to not only review our internal 3D platform and capabilities, but how we engage with other government departments, municipalities, and the private sector. We recognize there's a disconnect in how data is being used by governments, industry, and the community, often resulting in unintended disparate outcomes. The issues as we see it are, different parties are maintaining their own 3D based models in isolation. These groups are using conflicting tools to perform their spatial analysis, and many of the existing solutions are extremely complex to operate and limit the ability to collaborate and share data. We identified a clear need for a consistent platform and statewide 3D model that allows all levels of government and the broader community to perform analysis and visualization on existing built form, proposed developments, and overshadowing impacts. From there, we propose to build a scalable 3D platform to enable our stakeholders to collaborate, easily analyze, and visualize the future of Victoria. The solution was to start with a 3D web mapping platform and a detailed statewide dataset, along with a visualization capability. The solution was required to provide a high level of accessibility. It needed to be both available on devices we use every day like our smartphones, but also intuitive to use for anyone, not requiring lengthy training. Tapping into the existing spatial expertise within the planning group, our objective was to provide an innovative and fit-for-purpose solution. We could see what the problem was and we'd identified what our end goal state was. But how did we actually get there? Well, just like baking a cake, we wanted to ensure that we had all the correct ingredients before commencing the project. As a team, we identified what are the key elements which are going to ultimately make this project a success. And first up, data. There are plenty of 3D tools and technologies on the market, but unless we have the fundamental data sets and stipulated data management strategy, we'll be setting ourselves up to fail. We needed to determine a way to build out a full 3D base map for the state of Victoria, which is by no means an easy feat. And we also wanted to ensure that we provide some rules and recommendations around the format of 3D data being submitted to the department. Following on from that, technology. One of our early tasks was to review what are the available 3D tools and technologies on the market, assessing each's pros and cons. I guess like selecting a football team, where you want to ensure you cover all ends of the grounds and not end up with just a bunch of goal kickers, we needed to ensure that the technology that we chose was able to meet all facets of our requirements and not just a few finite areas. The key aspects that we were assessing included, does it provide the functionality we need out of the box, or is it adequately configurable to support our requirements? Is there a solid roadmap? What is the reputation of the product stack? And will it integrate with our spatial environment? And thirdly, people. We might have the highest quality data and the greatest technologies available, but without a user base that's engaged in the journey, there wouldn't be any success. Additionally, it's essential to have a team of spatial experts to not only drive the development, but support the development of enhancements well into the future. Finally, collaborating with other parties working in this space would not only allow us to share our learnings, but also learn from others who are leading the pack in this space. So altogether, we believe this would deliver a highly accessible, robust and powerful, modular and extensible 3D spatial platform. Along with the key ingredients though, our project plan outlined a series of steps that would ideally give us our best chance at success. Personally, I'm quite risk adverse, so I wanted to ensure that we were tackling this project in a structured fashion, identifying potential issues early and working collaboratively towards a solution. So starting in mid-2019, we spent considerable time working with our stakeholders to understand their end-to-end requirements, what their current toolset did well, what it could do better, and ultimately what they would like to see into the future. Following on from that, in late 2019, and based on our assessment and review of the technologies and tools available, we settled on a series of elements which we believed could deliver what we required. But before we went too far, we embarked on a proof of concept to validate the preferred technologies. As I mentioned, quite risk adverse, and I know all too well that the marketing material that comes with some tools out there sometimes can overstate their capabilities a little. So I felt it was imperative upon us that we ran our chosen tools through their paces first. And then from early 2020 through to now, once we were satisfied with the chosen technology stack, we developed a technical design and commenced the implementation of the 3D spatial solution. We tackled it with an agile methodology, which was in line with the development of our other spatial applications. Once we had a solid understanding of how the business operates and what their key requirements were, we performed an analysis and experimentation phase, developing the proof of concept you see on the screen right now. We decided to put the ArcGIS JavaScript API and ArcGIS Enterprise through their paces when it came to 3D web mapping to ensure it could deliver what our users were after. Some of the initial components that we focused on as part of the proof of concept included integration of 3D and 2D data, the development of tools to interact with the 3D base model, providing the ability to easily visualize highly detailed development models alongside the existing built form, and the ability to mock up or sketch new buildings from within the interface. Upon completion of our experimentation phase, we documented our findings and produced a design for the formal solution. We were satisfied that our selection of tools and technologies would be able to deliver the solution we were looking to implement. So what were the technical elements that we planned to use? Well, first and foremost, the ArcGIS JavaScript API. As you'd all be well aware, the API provides a great deal of functionality out of the box, along with an exciting roadmap of features ahead. It would also allow us to easily integrate with our other spatial systems and services within the planning group. Secondly, ArcGIS Pro. As you're all aware, with ArcGIS Pro, it provides a great deal of data analysis and management capabilities, and it allowed us to easily publish and manage our 3D spatial data into the ArcGIS Enterprise environment. The ArcGIS solutions for state and local government. This is a real hidden gem from Esri, and it provides a great range of tools to support planning and development. The key areas that took our interest were firstly the 3D base maps component, which supported the authoring of high quality 3D base maps, and also the development impact analysis component, which was a collection of maps and apps used to assess the physical impact of each new development on the existing community. Next up, City Engine, ArcGIS Urban, and Unreal Engine. City Engine has been used to some extent within the department, but we saw this project as a chance to take full advantage of the advanced 3D modeling capabilities it provides. Alongside this, we identified ArcGIS Urban as a powerful support to our urban planning projects that focus on the development of new precincts across the state. And finally, FME and Python. These would contribute to robust data processing and data management practices along with deployment processes. So what was the reasons we opted for this chosen technology stack? Well, firstly, technically it was able to deliver most of our requirements. Unfortunately, there was no single technology stack that would deliver everything we needed perfectly, but this stack would provide us with some great tools immediately with little configuration effort to get started. The stack also aligned with the broader spatial strategy within the department and would integrate seamlessly alongside the rest of our spatial implementation. It would also allow for a greater return on investment in our spatial environment, both from the technical implementation, but also the development of our team in the ArcGIS suite of tools and technologies. One of our key objectives was to not only deliver the solution, but upskill our team across the various aspects of the project. I'm now going to spend some time with you walking through the solution areas in a little detail. And firstly, I'm going to talk about data. As I've stated previously, we realized early on that the success of the project hinged on a solid data schema and data management strategy. With our solution not being solely focused on metropolitan Melbourne, we knew we had a large task ahead of us to not only build out a full 3D base map for the state of Victoria, but also provide other data sets that would aid in the analysis that needs to be undertaken within the application. The key steps that we followed throughout the phase of the project were firstly identifying what data sets we have available to us, what are the gaps that exist, and how do we plug those gaps? Secondly, we built out our 3D base map using ArcGIS Pro, the ArcGIS solutions, Python, and FME. Then we wanted to ensure our data management strategies were robust, automated, and streamlined. We wanted to ensure from the start that we had solid methods in place to manage the data and eliminate any manual processing and publishing of data. To achieve this, we utilize a combination of Python and FME to set up automated publishing routines, which would push the data to portal as soon as new as-built or development activity models were provided to us. The ArcGIS solution for state and local government provided us with some fantastic tools out of the box within ArcGIS Pro. The team was able to leverage these powerful features to fast-track aspects of the project implementation. For those unaware, the ArcGIS solution for local government and state and local government includes a series of focus maps and applications designed to help us leverage our GIS information and the ArcGIS platform to improve government activities and enhance services delivered to the general public. As stated, we focused on the following modules: the 3D base maps and the development impact analysis module, which provided us with a set of capabilities that helped us create solar radiation maps, evaluate how proposed developments will cast shadows on existing buildings, and review the impacts of viewsheds. By integrating these with other tools and processes, we were able to build out a full statewide 3D base map that's not only just used in Vic3D, but also our other ArcGIS web-based mapping applications. Overall, the ArcGIS solution workflows were really powerful, really easy to use, and streamlined a lot of the analysis that would have typically taken far longer to deliver. In regards to the web application Vic3D, the focus areas for version 1 included the ability to visualize existing built form and development activity data, the ability to undertake shadow analysis from within the interface, be able to calculate area and distance within the 3D scene, various viewshed tools, the ability to sketch up models when potential models aren't provided to us, and a camera tool capability to set up defined viewpoints and perform fly-throughs. I'd like to now showcase some of the features that have been delivered as part of version 1 of Vic3D. As stated, it's a statewide 3D viewer built using the ArcGIS stack of technologies developed to be easily accessible through a web browser. The application incorporates existing built form models, proposed building and BIM models, highly detailed mesh models alongside the Victorian planning scheme and other key data sets. We wanted to make it simple to visualize development activity and their status across the state, so we settled on markers which would bring in the building models when clicked upon. Highly detailed mesh models were incorporated to deliver realistic context for priority areas. We introduced the measurement tools available out of the box from the ArcGIS JavaScript API, and we also leveraged the dynamic symbolization capabilities available through the API to update how buildings look based on an attribute such as building height, along with filtering the dataset as required. Other functions we incorporated through the JavaScript API included the slice tool, which is useful for revealing occluded content within the scene view. We also incorporated visibility tools which support operations such as undertaking a line of sight analysis between 2 points, generating a viewshed analysis, or dynamically analyzing the view ray from a user-defined location. One of our most exciting features is the sketch function, which allows the user to create and analyze proposed buildings within the viewer. The tool provides the ability to define a building footprint, how many floors and building segments would make up the object. All of these sketch buildings will then be available as part of any shadow analysis undertaken within the viewer. Alongside the development of the JavaScript web application, we commenced investigating how we could potentially integrate and leverage our investment in CityEngine. This application has provided us with value when it comes to undertaking procedural modeling and scripting for planning urban environments. And we saw an opportunity to take this a step further by incorporating Unreal Engine into our solution for the creation of high-end visualizations. This video provides a brief overview of the workflow that we have utilized to take our base 3D data, which is used within Vic3D, undertake enhancements and further modeling through CityEngine, and ultimately deliver high-end visualizations. We commence by reviewing the development activity model submitted to us within ArcGIS Pro. We can then load that data we are working with into CityEngine and undertake any updates as part of this project, which may include the creation of additional proposed developments or the refinement or further refinements within the existing built form. Additionally, we can then go on and add street furniture, pedestrians, cars, using CGA rules to provide that extra level of realism. From there, we leveraged the DataSmith exporter to transfer the data efficiently from City Engine and into Unreal Engine Editor. We now have the ability to leverage the powerful capabilities of Unreal Engine to produce beautiful and realistic fly-through visualizations. Within Unreal Engine, we have the ability to apply high-quality renders and walk or fly through the project in real time. This also includes the ability to update lighting settings based on the needs of the project we are presenting. Ultimately, this workflow provides us with a great mechanism to produce high-end visualizations that can be used efficiently as part of community engagement and other forums of this type. So far, the solution has been received really well from our stakeholders, but that could just be because it's 3D and everybody loves 3D. But I now wanted to run you through some of the immediate use cases that the platform is being used for. And one of the primary functions of our 3D platform is to provide a mechanism to easily visualize proposed developments across the city. When a building model is submitted to the department, it's automatically published to the platform, making it easy to analyze within the existing context. When multiple versions of a proposed development are submitted, planners can easily pivot between the two to review changes made. But then when building models aren't made available to us, planners need an efficient method to quickly mock up a proposed development from within the interface. This is supported through the sketch function, which allows users to easily create buildings, segments, and different setback configurations. Using a 2D web map integrated within the application, the user will define the building footprint and any initial setbacks. Then any number of building segments can be defined with number of floor height, along with further setbacks. Once complete, these buildings form part of any analysis undertaken within the viewer, including the impacts of overshadowing. In this scenario, though, we want to see if the proposed development will violate any restrictions, for instance, conflicting with building height controls in the city. There are also scenarios where we need to conduct visibility assessments for existing and proposed buildings. Planners can assess the visibility from or visibility of a proposed development within the existing built form. For starters, we can look at the level of visibility for the Yarra River from this proposed building we can see. The analysis shows that there's a higher level of visibility over the course of a single day for the higher levels, marked by that increased intensity of shading. Secondly, analysing solar radiation calculations can empower our planners to review building potential for solar panel installations. Vic3D provides the ability to review the solar radiation, both for the existing built form and how that changes with the introduction of a newly proposed building. This will help determine the ideal location for solar panels and the impact on existing solar infrastructure from new buildings. And planners can also solely focus on the potential shadow impact of a proposed development on the surrounding buildings. In this scenario, we can assess the existing cumulative shadowing over the course of a single day, then compare that with the cumulative shadow after removing the existing building and introducing the new development. Unfortunately, though, this doesn't highlight what has been introduced, but we can pivot to the shadow difference between the pre and post development. And this makes it simple to see which areas are affected by the newly introduced shadowing and the intensity of that over the course of a single day. Finally, the ability to generate realistic, high-end visualizations using a combination of existing built form and what's potentially possible has been a great option to have to us. As governments around the world have struggled to find ways to keep their economies going during the coronavirus pandemic, one initiative from the Victorian government is to encourage outdoor dining, increasing the allowable space for these kind of arrangements. Taking this area in Bendigo, which has a high potential for outdoor dining, and leveraging the great photo mesh data we have in the city, we could model up how this could look upon taking advantage of the new rules around outdoor dining. The end result, developed using Unreal Engine and the data from our Vic3D platform, provides a great way to consult with the businesses in the area to show what's potentially possible. From our perspective, the most exciting part through all of this is the fact that we in the planning spatial team can now generate these visualizations from start to end. The tools are all available to us through the ArcGIS platform and the associated products, which all integrate really well together. With the successful deployment of version 1 of Vic3D, we took a step back and reflected on how far we'd come and what were the benefits delivered to the department. Firstly, we've delivered a solution to our stakeholders which will not only support their current needs, but has also opened up a great deal of potential to do more analysis and ultimately have more data at their fingertips. As soon as a building model has been submitted to the department, FME detects the new model, interrogates the aspatial database for related attributes, and publishes the model to Portal, making it immediately visible through Vic3D. Planners no longer need highly skilled technical people to help them review development activity. They can easily do it themselves whenever and wherever they need. We now have an empowered spatial team within planning. The team has had the opportunity to not only learn new technologies and skills, but they've also been empowered to use those skills and benefit the planning group. The extended use of the ArcGIS JavaScript API has also opened up a range of opportunities to develop other more targeted web applications to support the planning department. And we've also developed some really strong relationships with key parties, not only within Australia, but around the world. Esri has been critical to guiding us through some of the more complicated aspects of the project, and companies like Aerometrics in Australia have delivered fantastic data sets and expert assistance along the way. And of course, the project has allowed us to play with some pretty cool technologies and toys. But it doesn't end here. There are still a lot more exciting functions and tools to explore and introduce into our 3D solution. Some of those include in our road ahead, enhanced shadow analysis. There's a lot of potential to further enhance what's possible through the analysis of overshadowing, including isolating shadows for a single building and on-the-fly accumulative shadow determination. We're really excited to see what Esri has in store for both the ArcGIS JavaScript API and ArcGIS Urban when it comes to that type of advanced shadow analysis in upcoming releases. Also, the introduction of visualizing real-time data within the viewer. We believe this will really support planners in making the most informed decisions at all times. And finally, a focus on leveraging and exploring what's possible through VR and AR within our application to further expand on our visualization capabilities. So after all that, what have we learned along the way? Well, firstly, there's no one tool for the job. There are so many great components across the ArcGIS suite, and while it can be daunting to keep across them, it's really worthwhile investing time in researching what's available along with talking to people experienced in this space. Our research ultimately showed us that by combining various aspects of the ArcGIS stack along with other spatial tools such as FME, we're able to build a really exciting and powerful 3D solution. Business case management buy-in. Without a solid business case and without management buy-in, we wouldn't have been given the latitude required to develop such an innovative solution. Availability and accuracy of data. As much as we would love to have the highest detailed data across the city, you only really need data as detailed as your business case demands. Going beyond that only puts unnecessary strain on your system and of course on your budget. Accessibility and user interface design. This is fundamental to the success of a project like ours. What you or I think is user-friendly isn't always going to be user-friendly to the planners and the associated users. So ensuring the application is accessible on a range of devices was a really big contributor to getting our end users on board. invest in your people or your team. Projects of this nature are a fantastic opportunity to fast track the development of your team. I've been so proud of the way that my team's worked over the last 18 months to upskill and ultimately apply these new technologies and understandings to develop such an amazing system. And finally, collaboration. This project has demonstrated the value of a great collaborative working relationship, not only within the spatial team in planning, but with entities such as Esri, Esri Australia, and the likes. The success of projects like this are heavily dependent on us working together, learning from one another, and ultimately driving each other to bigger and better things. So, in closing, I'd like to thank you for your attention. I hope that you've really enjoyed coming along with us on the exciting journey of empowering planning to be done more efficiently in 3D using the ArcGIS platform. On the screen are some of the people I'd like to acknowledge who have really been integral to the success of this project. Starting with the team from DALP and led by Jujia Shen, Al Bios, Tim Gray, Darren Green, and Ran Pan. And of course, from Esri, Christine Mars been fantastic, Robert Clout from Aerometrics when it came to data, Gordon Sumling from Esri Australia, and of course the whole GIS team at City of Melbourne. I encourage anyone who's interested in discussing this solution in more detail to reach out, because we're always looking to collaborate and share our learnings further. Thank you very much for your time.